Hi there, welcome to High School Maths. Today we're going to have a quick look at a couple of different skills and common questions involving algebraic fractions. So we're going to start off with simplifying and factorising, which kind of tie in together in some questions. Factorising is not going to come into everything, but we're going to look at some simplifying to start off with. So for this first question, we've got 10a over 5. Just like a normal fraction, we're looking at numbers to see is there anything we can cancel down there for the numbers. They're both in the 5 times table. If they're both in the 5 times table, we can divide both of the numbers by 5. And that would give us 2a on top and 1 on the bottom. Now, you don't leave a 1 on the bottom of a fraction. That's just the same as 2a. Okay, so 2a divided by 1 is just 2a. There was nothing we could cancel out with the letters. There was only one letter term or letter as part of the term, so we couldn't simplify or cancel down there. But if you look at the second example, we've got 3c over 6c cubed. Again, we're going to start with the numbers. We've got one term on top, one term on the bottom, so we're going to cancel down the 3 and the 6. They're both in the 3 times table, so we're going to divide them both by 3. That's going to give us 1 on the top and 2 on the bottom. Now, the 1 on the top you don't technically need, but it might help just to show kind of what you're doing. Now, if we look here, what we've got is we've got a c term on top and we've got a c cubed on the bottom. What we want to do is we want to cancel one of these, this c, with one of the c's that are on the bottom. Remember, c cubed is c times c times c. So it's like having 3 c's. So we're going to cancel this c on the top with one of these c's here. That's going to take that one away altogether. That's going to leave you c squared on the bottom. So we're going to have 1 over c squared. So 1 over 2c squared as a final answer here. Now, if the 1 is on the top, we can't leave that out. Okay, we have to have the 1 in the top line of the fraction, so 1 over 2c squared. If it was on the bottom, like we had in the first example, then we could leave it out and just have 2a. Now, on to something a little bit more complicated. We've got 3 bracket x plus 1 all over x plus 1 in first bracket 2x minus 5 in second. This is already written in factorised form. So the fraction has been simplified into a factorised form. What we're looking for is we've got one big term on top and one big term on bottom. That's important. This 3 bracket x plus 1, that's all one term, and the x plus 1 in the first bracket times the 2x minus 5, that's all one big term in the bottom. And providing that's the case, we can cancel out. So here we're looking for things that are similar on top and bottom. And what we're going to do is cancel this x plus 1 here with this x plus 1 here. Those whole brackets cancel each other out, just leaving us with 3 over 2x minus 5 on the bottom. Okay. That's as far as we can go with that example, but in the next examples we're going to look at how the factorising process actually works when you're dealing with fractions. Now, it's the same process you've always used for factorising. So if you look at the first one, 4x minus 2 over, the bottom line's already in factorised form, so that's handy. But the top line, we've got two terms. We've got a 4x and we've got a minus 2. So we have to try and see if we can factorise that in some way. And the way we should always start is look for a common factor, which we do have here. So anytime you're factorising, always look for a common factor first. That's 2 bracket 2x minus 1, because they're both in the 2 times table. All over, and we're just keeping the bottom line the same. Now, if we do that, hopefully what we can see now is we've got one big term on the top. It's 2 times this whole bracket, so that's one term, and one term on the bottom. We can cancel out the 2x minus 1, similar to what we did in the previous example, on top and bottom, and that leaves us with 2 over x plus 4. You don't need to keep the brackets in the bottom line, but I find it helps a little bit, so 2 over x plus 4. As your final answer. Just watch there, you can't go cancelling all the way. The 2 here can't cancel with this 4 because everything in the top line is in the 2 times table, but everything in the bottom line isn't. The x term isn't in the 2 times table, so we have to be careful how far we actually cancel down. Okay, and the last one. So this is your typical example, and what it might say in a kind of question leading up to this is factorise one of these expressions, either the top or the bottom, and then ask you to simplify the fraction as a kind of lead into the question. So if we look at this, they're both not factorised, so we're going to try and factorise them. Now, there's no common factor in the top line. It's not a difference of 2 squares, so it's a trinomial. And on the top, it's quite an easy one. X times x to give us the x squared, 2 times 2 to give us the 4, and a plus and a plus to give us the plus 2x and the plus 2x, which makes the plus 4x. That's how we factorise a trinomial. The next one, on the bottom, we've got x squared minus 4. Again, check for a common factor, but there's not one here. Then a difference of two squares. It is a difference of two squares, so we're going to do two empty brackets at the beginning, x times x to give us x squared. At the end, 2 times 2 to give us 4. And in the middle, a plus and a minus. And the signs need to be different in the difference of two squares, so we cancel out this middle term. Again, we're looking to see if there's anything similar. And here, we've got an x plus 2 on top and an x plus 2 on the bottom. So we cancel one of the tops with one of the bottom. And all we're left with is x plus 2 on the top line over x minus 2 on the bottom as our final answer. Again, the 2's and the x's can't cancel out here. They're all separate terms, so there's no common factor that works all the way through. Be careful with how far you're simplifying down your fractions. So that's your first kind of common type of question involving algebraic fractions, and it can come into the next part we're going to talk about, which is our operations with fractions. So let's have a look at that. Now, we've got 4 examples here, and we're going to go over just a mixture of the different kind of questions that come up on algebraic fractions. So starting quite simple, moving on to more complex. The same rules for your 4 operations with normal numerical fractions work and apply here. So for adding or subtracting, we need a common denominator. If we look at this first fraction, the common denominator should be fairly straightforward. You're looking at the 5 and the 2 times table. What's the first number that comes up in the 5 and the 2 times table? 10. So that's your lowest common denominator. Now, for the first fraction, it's gone from a 5 on the bottom to a 10. That means we multiplied this first fraction by 2. 5 times 2 is 10. A times 2 is 2a. So that's our first fraction that made equivalent. The second fraction has gone from a 2 on the bottom to a 10. So it's times by 5, or multiplied by 5. We're going to do the same to the top. B times 5 is 5b. And we now have a common denominator, so we can add these two together. And when we're doing that, all we're doing is putting the top line together because they're different terms. So 2a plus 5b all over our common denominator 10. And check to see if there's any simplifying you can do. There's not here. None of the numbers are common. So 2, 5 and 10, they're all in different times tables. And that would be our final answer. So let's have a look at another one. This time we're going for a dividing, which kind of covers multiplying as well. Remember, your first rule for dividing fractions is to flip the second fraction and change it to a times. So we get something like that. Then it's top times top and bottom times bottom for multiplying fractions. So the divide changes to a times, and then you just do your same kind of operations or process for multiplying two fractions together. So 3c times 8c, 3 times 8 is 24, c times c is c squared, all over 6 times 2 on the bottom is 12. This one does cancel down. You can see they're both in the 12 times table. So here we've got 24 divided by 12, so dividing that by 12, dividing that by 12, we cancel down, we get 2c squared over 1, or just 2c squared. Again, it's up to you how much simplifying you actually need to show. If you want to just jump to 2c squared there, then you can. You could also cancel at this stage here, when you reach the multiplying stage, across the fractions. You could see that the 8 and the 6 would cancel down, and that would maybe make things a little bit simpler. It's entirely up to you where you do your simplifying. Okay, let's have a look at something more complicated with a bracket. Now, this one's subtracting, the last one's subtracting as well. The rules are same for adding and subtracting, remember. Get your common denominator and then work through the process. Multiplying and dividing is a little easier, but also a little less common with these types of questions. So let's jump into this. We need a common denominator for two fractions. The easiest way to do that is to when you've got something that's complex on the bottom of one of your fractions here, is just to multiply the two bottoms together. So our common denominator, so we're going to give ourselves plenty of space. We're going to have two fractions with a takeaway in between, is going to be 5, this one, times this one, bracket x plus 1. So that's going to be our common denominator. Now, remember, we need to change the top line, the numerator as well. So this first fraction, we already had the x plus 1, we've multiplied this one by 5. So 5 times 3 is 15, just that exact same process we had in the first question. The second fraction, we've multiplied by x plus 1, because the 5 was already there, but we've multiplied that by x plus 1, so we need to multiply the top by x plus 1 as well. And if we cancelled out those two brackets there, we would go back to x over 5, which is what you should have with an equivalent fraction. Now that we've got a common denominator though, we can put the two brackets together, so it's two fractions together, minus x bracket x plus 1, all over your common denominator, 5 bracket x plus 1. Okay. It can start to get quite a long process, but it should get a little simpler as you go down. Now we've done the hard part, we've got it as one single fraction. We just want to simplify the top line here. So 15. Now remember, it's a negative x in front of the bracket, so negative x times x is negative x squared, or minus x squared, and negative x times 1 would be minus 1x, or minus x, all over. It's tempting to multiply this out, but actually it's already in factorised form, 5 bracket x plus 1, so we'll just leave it there, 5 bracket x plus 1. We're just going to tidy up this top line for our last and final answer. We're going to put the in order, so negative x squared first, then a minus x, and then a positive or plus 15 at the end, all over 5 bracket x plus 1. And that would be enough to get us our marks for that question. Okay, and let's jump on to the last one. The last one has two fractions, but we approach it in the exact same way. I'm going to try and squeeze this in here. So we're going to have to get our common denominator first, and oh no, it's already got a common denominator. Let's change that to a plus. Silly mistake there. So we're going to have to get a common denominator, and to do that again, we're just going to multiply the two bottom fractions together. So we're going to do 2x minus 3 times 2x plus 3 as our common denominator. Just ignore the fact that I had them the same at the beginning. That was a mistake on my part. Okay, same idea as previously. Change the bottom, we change the tops. So for the first fraction, we already had a 2x minus 3, so we already had this. What we multiplied by was 2x plus 3. So we're going to do 1 bracket, we're going to multiply the top line by 2x plus 3 here. And for the second fraction, we already had a 2x plus 3, which we've kept, but we've multiplied that by 2x minus 3. So we're going to keep the 2x on top, but we're going to multiply that by 2x minus 3. Now that looks really complicated, but it's just the same process. It's just because you're dealing with brackets, it looks more complicated. Now if we multiply out the brackets, what we'll do is put the top lines together first into a single fraction. So it's 1 bracket 2x plus 3 minus 2x bracket 2x minus 3 all over your common denominator. Remember, that's the whole point of getting the common denominator, so that we can put the two fractions together. Okay, we're going to multiply at the top line and just tidy that up a little bit now. So 1 times the first bracket, that's just going to be 2x plus 3. Okay, so 2x plus 3. That's 1 times that and 1 times that. We're multiplying the second bracket by negative 2x, so it's going to be minus 4x squared for this times this. And then negative 2x times negative 3 would be a positive. Remember, negative times a negative is a positive, so that would be plus 6x all over. And again, keep your bottom line in the factorised form, or the bracketed form. It is simpler. So 2x minus 3 and 2x plus 3. We just have to tidy up that top line now. There's a little bit of collecting like terms we can do. We have a minus 4x squared, so let's put it in order. Highest power first. We've got a 2x here and a plus 6x here. That's a plus 8x altogether. And then for the number, we've got a plus 3 at the end. All over, and our brackets 2x minus 3, bracket 2x plus 3. And that would be our final solution there. Okay. I know I've gone through that quite quickly. If you need to play it back at 0.5 speed just to kind of follow that, please do so. I'll talk really slow and deep, but it'll be fine. Hopefully you found it useful though. For more videos and resources, please visit highschoolmaths.co.uk, and if you like the video, click that like button and subscribe. Please remember to share the video. Thanks for watching, and have a mathemagical day.